Okay, last one to get de-dusted. This is the Stryker SR955HP, and without the camera in my face, I was able to look this thing over a little bit closer. Yeah, it's got more parts changed in this than I initially thought. At looking at it from about 1.5 feet to 2 feet away, there's a lot of hocus pocus going on over here too. Not just the black goop encased mod. This stuff here. this it's original. It's just funny. Oh God. Every day you think you say I've seen it all. Well, yeah, and then you turn around and where is my pointy stick? This damn RF shield's gonna get halfway in the way. It's hard to see. Let's see, where are we at? You see that? That's a surface mount resistor. Standing up. Not soldered flat on the board. What in God's name is up with that? Oh, and there's another one. Yeah, that's another surface mount resistor standing up with a wire soldered to the top side of it that goes down to the board. That big diode and this resistor with a ferrite bead, I'm not going to lie, I'm not sure about that. I'm going to have to look at the schematic. It doesn't look factory, that looks bodged here, but I'll have to check and verify. But without a doubt, there is absolutely no way that is factory, or that bullshit right there is factory. I mean, really? I have never, ever, ever seen anybody stand a ceramic component, period, not just a resistor, any ceramic SMD component, up on its edge or on its end. Oh, yeah, we got these big glob of solder here for some reason. I don't know why we felt we needed that. It looks like this has got huge globs of solder on it. That's definitely not original. That wasn't done in a reflow oven. And yeah, looks like there's a trace has been ripped off right there, so I'm going to have to pull out the board layout and the schematic and take a look at it and see what I mean, really, people? If nothing else, working on radios like this is good for a laugh. That's picture worthy right there, man. That's a hang it on the wall. And I don't think I saw anything, and you know, as soon as I say that, I'll probably spot something. But I think everything over here, the regulator circuit on this side of the board at least, looks to be original. You're actually seeing this better than I am, because again, I'm actually looking through the viewfinder of the camera. So, but yeah, that doesn't look too bad. It just looks like most of the damage is over here in this section, right in front of the finals. And let's see if we can get the rest of this goop out of the way. Get the camera over here out of my way. And get this in, where are we at? Get it in view. And we'll see if we can get the rest of this goop peeled off of here. Oh, I just broke the diode, which I could really care less. It's going to go bye-bye anyhow. Yeah, but again, surface mount diode. I can't even see my viewfinder. Surface mount diode mounted, standing straight up right there. You know, bodged to this trimmer resistor. I mean, really? No wonder they've got this black goop on here. What a mess. At least this stuff comes off. Because, man, this could get expensive if this was epoxy or something, you know, that got really hard. And actually, like that Lincoln that I undid this stuff to, that one, all that goop was on the solder side of the board, so that may have been a right to radio off as just lost calls. So it looks like that is, am I still, no I'm not in camera view. That's just a trimmer resistor, has one leg attached here, went to a diode that was soldered right there where it's broken off, and then down to the board. So actually that's something you see in a lot of radios. Again, that's just one of those high power hocus pocus modifications. It looks good on a watt meter. You know, you'll have your needle slapping the right side of the meter scale, and it's doing, all it does is make you sound absolutely horrible on air and just shorten the life of the radio, because you're just going to be burning out parts. So yeah, I'll get that unsoldered off of there. Actually, I should stick a diode back in there, because you haven't actually seen, and I haven't either. I am curious to see how bad is the transmit on this thing. So let me get this goop off of here. I'll just temporarily tack a diode back in here so we can see what exactly is, how bad this radio is, before I go in doing all of this stuff. So let me get that cleaned up, diode installed, and I'll be back. Okay, so I've got the radio powered up and finished removing the black glob of death. Got the diode reattached there, and without the camera in my face, I really got a good look down in here. Oh yeah, there is a lot of changes. I didn't think there was much, if anything, done over here. Yeah, I stand corrected. Man, there's all kinds of shit has been changed. So let's first take a look at what this radio actually does. Where is the power? No, that's RF, right? Yeah, okay. RF power up the whole way, and we are in AM. So let's take a look over here. And with the RF power turned up the whole way, that watt meter is set in the 20 watt scale. And 15 watts, that's maximum. Like I say, I don't work on a lot of Strykers. I'd have to pull 4.5 with it turned down the whole way, and a 15 watt carrier when it's up the whole way. I don't think that's right. I'd have to pull, I don't even, let's see, what does the service manual say here? Transmit. FM, high power, should be 50 watts, so let's put it in FM. And it does 17 watts in FM with the RF power knob up the whole way. It does from, what, less than a watt to 17 watts. And according to the service manual here, FM high power, choosing adjust power for maximum, adjust heavy routine to get 50 watts plus or minus 2 watts. Wow. So we didn't do a power modification in the normal sense of most people's modifications usually give you more power. This one apparently gives you less power. So let's go back to AM, because nobody, of course, people that own these things, they're not using them on FM. And let's take a look at the modulation. Mic gain, where the hell is that on this thing? Right there. Okay, mic gain's up the whole way. And we are in AM. Audio 1, 2, audio. Imagine that. Rail cars again. And we'll go to sideband. I'm going to assume this thing can do over 20 watts on sideband. I would hope so. Audio. Audio. And again, we have the big wide fat bar. Audio. Does like 55 watts, maybe a little more on sideband. So yeah, this... Oh man. What did they do to this poor thing? So, actually, let's see if we can see exactly what in God's name has been done to this thing. I had said about some stuff I hadn't seen before. Like I say, the camera in front of my face, I'm always, my head so far away, I can't see half of this stuff until I get the camera swung out of the way and look. What in the hell is that? A surface mount resistor standing on its edge. What? Better yet, There's another one! Right there! Surface mount resistor, standing on its edge. But this one's not on its edge, it's standing on its end. And it has a wire soldered to it that then goes down to the board. Where the hell are all the parts that are supposed to be soldered back there? In here? There's parts missing here. There's parts missing here. This diode is not supposed to be here. This resistor, this ferrite bead is not supposed to be here. So actually, let's just take this cover off. Take the brass plate off there. A little heat spreader, because that should have, and that's a P2. So we have a mix of P2 and P3 screws, or P2 and P1 head screws. And what's that one? That one's a P1. Come on. And the last one. Which the brass spreader plate actually is a decent idea on these, because with the sill pad, that'll help to dissipate a little bit more heat off of those FETs, and then helps to transfer it into the aluminum chassis and heatsink. That's what the sill pad there does. The problem is there's no heatsink compound on here, and you're actually, if you want to use this for heat transfer, you should have heatsink compound on here in between here and here. But so let's see, do these all look like they're original? Let me pull it out here and look at it. Huh. Okay, it's got an FQP 13N10. And thinking about the terminology here, because this is different than, like I say, than like a Lincoln. A Lincoln has a pre-driver, a driver, and a pair of finals. These radios, they add another one. These are not modulated. So I guess actually what you could consider this as is a pre-driver, a driver, a final, and then it has, for all intents and purposes, you could consider these as a separate 2-transistor amplifier. It's a little standalone amplifier, basically, is kind of the way this one's set up. But these are IRF 520s. That is a 13N10. I don't know. The schematic, I think they're supposed to all be 13N10s, aren't they? Yeah. Uh, 13N10. 13N10, 13N10, and 13N10. Yes, they should, all four of them should be FQP 13N10s. So I'm guessing the magic smoke got let out and they've maybe have been replaced, but more importantly is that's not supposed to be in here, that's not supposed to be in here. That is definitely that sideways surface mount resistor. That's just, oh, that's a classic, man. That's not supposed to be in there. That's not supposed to be in there. There's parts missing here. There's parts missing here. You know, I kind of wonder, you know, I'd have to trace all this out. Did they possibly, because you see this, the original versions of these radios did not have this actually they didn't have any of this circuitry right here. Because originally, the original Stryker SR955s, they were known for doing one thing, catching on fire. This area here would burst into flames, quite literally yellow-orange flames coming out of your radio and lots of smoke. That's because they were volted. They've put in a switching circuit here that prevents that now, so it's the anti-smoke circuit basically. And like I say, that apparently has been worked on, because that is not factory soldering. Huge globs of solder. These parts were installed, in a reflow oven. So, all of these parts in this radio were installed. There was solder paste applied to the board. The components, a pick-and-place machine, placed the parts on the board, and then it went through a reflow oven. So those should be nice, just barely any solder visible, barely around the edges, just a nice little fillet of solder. That's been worked on. So did this burn out at some point already? But yeah, there's that diode is not supposed to be here. There's supposed to be, I think, like a pair of large resistors. There's supposed to be a diode somewhere in here. There's some parts missing here. Now some of these I think are actually supposed to be empty. Again, I'll have to look at the board layout and the schematic, but these trimmer resistors, these are not original either. They should be these, the blue plastic ones with the white top. If you look at all the other ones in this radio, you can see same thing. They're all blue with the white tops. So obviously both of these have been replaced. So yeah, man, I got to get the fine-tooth comb out again. And I was hoping it was just going to be as simple as undo that and that stuff, and that would be about it. Now, yeah, insert foot in mouth again. So it looks like, yeah, I definitely got my work cut out for me here. This was but I don't think, actually, let me pause the video. I've got, and I don't work on a lot of these. Like I say, for my customers, these radios aren't really that popular. I work on a lot of older radios, and I don't know if maybe the which I'm going to go get, of radio that actually did catch on fire and show you what I mean by the circuit differences. But yeah, for a lot of the people I work on for radios, they're not big fans of these things. Other people love them. They are high power radios. Like I say, very similar in design to a Lincoln. Don't get me wrong, a lot of differences, but there's also a lot of similarities. But there's actually more similarities than there are differences. But yeah, man, this thing has been why would you do modifications that reduce power and actually reduce the modulation? This radio should do a lot more than it's doing right now. I don't get that. What's the point of doing a modification if it, obviously, even on a watt meter, because that's usually what most people do. They do modifications to make it look good on a watt meter. See, your needle goes up farther. You can smack the right side of the meter face. This one won't do that. Not that it has an analog meter to start with, but it wouldn't be a needle smacker anyhow, because it's doing less power even on the meter. I don't get it. What was the purpose behind this? And I kind of get the feeling what they did here. That's what I said. I'd have to try and reverse engineer this, trace out some of this circuitry. Did they try to volt the driver possibly? Because that gets, I think it's 8 volts in these. Maybe some of this modification was to volt the driver, which then of course is going to overdrive, because that circuit's going to be producing more power now, which is going to overdrive the amplifier. Well, then it was horribly distorted, so they had to possibly do all these other modifications to reduce the power on the amplifier stage. I don't know. I just head shaking. Yeah, why? Oh, let me go get that other chassis, and I'll show you what a smoked 955 looks like. Okay, so here is a 955 chassis from, get the reflection right here, what is that, a 2012 board, where this one I think is a 2015 board. Yeah, 2015 down there, the date code on the PCB, and this one's a 2012, so this is an earlier version. Notice that FET and all of the supporting components that you see in this one, that circuit right there, it's not present in this one. And also notice how black the circuit board is. That's because this had caught on fire. So, but this is actually, most of this circuitry still stayed the same. What they did was is added that control circuitry over there. But you can see what this is supposed to look like. There's not supposed to be, let me get my pointer again, get my big meat paw out of there. There's not supposed to be a big diode right here with a resistor here with a lead that comes out. Surface mount resistor standing up here, one here. You can see, well, actually this has that transistor. That actually goes away, I believe, in the later versions of these radios. So that's actually another change, that from this version to that radio over there, most of these components should be missing. On the newer version radios, the pads are still there. They didn't respin the board. They just didn't put the parts in. But yeah, you can see that resistor's missing, that's missing, that's missing, that's missing off of that board over here. Missing, 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 missing. And there's the other parts I was talking about. If I just bring this one back into view, you can see should have two resistors there and a diode going front to back. We have a diode going side to side and a resistor back there. So yeah, just why? But yeah, like I say, this was the later version. This was the flame, or I don't want to say flame proof. Nothing's flame, nothing electronic is impossible to destroy. But this was to prevent the radios from bursting into flames. So, but yeah, I just get the feeling somebody tried volting some of this circuitry, ended up overdriving later amplifier stages, and then ended up modifying them to reduce the power. The net result was a radio that doesn't even do advertised power anymore. I mean, I don't get it. And Stryker, Jesus, you think you could? You can now. Don't get me wrong. I'm not one of those people that when I see an IF transformer can slightly sideways, I don't do backflips and howl at the moon like some people do. Some people say, "Oh, they all got to be perfectly flat and square." And trust me, if the transformer can's a little bit crooked, it's not going to hurt anything. But Jesus, it's not just one trimmer resistor's crooked. That one's lopsided. There's a couple more back here that are horribly crooked. That one there, you can see how crooked it is. Those things are barely in the lead. That lead right here is barely touching the circuit board. It's so crooked. You know, when the pick and place machines puts these things in here, they need to, I mean, I understand when shit's made in China, they don't pay their employees much, but you need to go hire another guy to just follow behind the pick and place machine, come in and push these through hole parts to make sure they're through the board the whole way. So, yeah, because that's that's kind of, it doesn't affect the radio at all. They don't need to be straightened out. There's nothing wrong with the way they're mounted in there. Don't get me wrong. I don't want you to give you the impression that a crooked trimmer resistor is going to affect the performance of the radio. It's not. It's just a cosmetic thing that, yeah, you'd think they could at least get, you know, I could see one, the machine didn't release the vacuum fast enough, and when it pulled away, it started to pull it out a little bit, but yeah, they just got some really lopsided stuff in this thing. Okay, so before I get the new correct parts reinstalled, I thought I'd show after the removal of everything that shouldn't be in this radio. So actually over here are all the parts that were removed. So we got the two trimmer resistors. I'm not even going to bother checking the value. I had to take them out just to get in for access to some of the other stuff, but they've been changed for some reason, so I'm assuming they're probably just going to be the wrong value anyhow. There's those two poly caps that were on the bottom. That was that other trimmer resistor that was on the solder side that had, wherever it is, oh there it is, that little diode attached to it. The other two large diodes, and then the two those things are like, what, 2510 size, I guess? That's like a half-watt SMD resistor or something. But yeah, those two. And this one, you can see what I was talking about. It has a wire soldered on it that comes down the side and then hangs off the side. Yeah, that is absolutely the first time I've ever seen that done in my life. That's a first. And then that other resistor and ferrite bead, the little resistor rolls away. So that's all that stuff removed. So we look down in here now. Come on, hocus pocus focus. And you can see we've got all that stuff taken out. So the two trimmer caps, all the other crap that was bodged in here. Got the traces cleaned up. I need to look at the board layout diagram now and see exactly what needs to go back in here now. Make sure I get the correct values and everything. This trace that's missing here, this one pad, I'm going to have to check. Like I said, I'm not even sure if that's even needs to be in this radio, because the transistor that was in the earlier versions of the radio, this is no longer used in these later revision radios, but those two need to go in. Those two, all the parts that go over here are missing, need to go in, and trimmer resistors. I did remove the glob of solder that was on here, put that back to the way it should be. Same thing with this FET. I cleaned that up a little bit so it's not a gigantic mountain of solder on there. And then on the bottom side, cleaned all this up. Took those huge mountains of solder that was on some of this stuff, cleaned it up. Yeah, I don't know what, there'd been soldering over here. There was no modification here, but this had all been resoldered. You can even see the solder mask has been rubbed off, and I don't know what, did they use a wire brush to clean radios? Because if you look at the solder, you can see bristle marks in it. I don't know how well it shows up in camera, but there's scratches in the solder everywhere in this area, you know, except for where the fresh solder is, where I just soldered. But yeah, they clean these with a wire brush? I don't know. You shouldn't be using a wire brush to clean circuit boards. I can't see a nylon bristle making marks like that in the board, but I don't know. And then over here at the AM regulator, again, removed the trimmer resistor that was here, that was bodged from there, in series with the diode that goes down to this electrolytic capacitor, because that's actually what's on the other side of the board here, is that small electrolytic capacitor. So that's been removed, and nothing needs to go back in there, and nothing needs to go on the bottom side of the board here, because there's not supposed to be any parts on the bottom of this board. So let me go pull out some parts bins. Need lots of surface mount parts here, and get this thing restuffed. Now, actually, when I did the President Lincoln for the same customer, because it had the dust mod too, I guess, a couple people had commented, was that worth it? Getting that fixed. You know, they're like, well, you put all that money back into that radio. Well, the customer now owns the radio. It's his. Money's gone. He's got a radio. It doesn't work worth a heck. You know, he can't use it. It's just was completely unusable on air, like this one. You know, it's pretty much unusable, and it's not even doing what it should be. This one's actually doing less power. So, you know, basically, you've already invested your money in a radio. It's a brick now. If you can't use it, you might as well just go use it as a paving stone in your garden. You know. So the money that he's going to spend getting this working is going to be a lot less than buying a brand new radio. So is it worth it? Well, yeah. I mean, considering the other option is the radio just goes in the trash can, or, you know, like I say, you take it outside and use it as a paving stone. So, you know, that's your two options. No longer use it, or fix it, you know, basically put it back to stock like it should be, and you've got a good working radio again that will be reliable, and that's probably the biggest key. Though I don't know how unreliable this one would have been, because it apparently was underdriving. I guess, I don't know. I get the feeling the output power was increased here, but then they had to decrease it in later stages. And honestly, I wasn't going to reverse engineer that. I'm not going to charge the customer for sitting here drawing this out on a schematic, trying to figure out to tell him this is exactly what they did. It just needs to go. I could care less why they put it in there. It doesn't work. It went bye-bye. The stuff that does work is getting put back in. So let me get it restuffed with some parts, and we'll fire it up and see if she works okay. Fingers crossed. It worked with the Lincoln, I'll put it that way. Okay, so got all the new parts put in. As Louis Rosman would say, repeal and replace the parts. So we have repealed all of the bad parts that shouldn't have been in there, and we have replaced them with basically what the factory intended. And it came back working just like it should, not distorted. So I've done an alignment to it, and I think this is only like the second, maybe the third 955, maybe third or fourth, because I did have one. I think that was I'd have to go back and look at my own video. I think I had one. I didn't work on it, but a local customer brought one in that had, I think that's the radio that had that AC or ASI mod, however you pronounce it, in it, and I just did a review on it because I had never had one of those on the bench. I think that was a 955 too. And I think I see why people like these, and I may have to get one just to play around with, because actually it's kind of impressive if you leave the radio stock. It runs cooler than most radios. So for starters, max mod people waste of time in these radios. Absolutely useless. It serves no purpose to stick one of those things in here. The AM regulator in these radios does not get that hot because because it's not doing much in these radios. Unlike most other radios where the finals are modulated by the AM regulator, remember, the finals in this radio are not modulated. The only thing that pair of finals does, which like I say, we shouldn't really call those finals, we should call them an amplifier. We have a pre-driver on the side here, we have a driver, or actually we have the pre-driver, the driver, a single final which gets modulated, the driver and the final get modulated, and then the amplifier transistors here, or MOSFETs, do nothing but amplify what is coming out of the final MOSFET. So in this radio, the AM regulator doesn't have to do as much work because it only has a driver and a final. It's not modulating a driver and two finals like in most other radios. Because they're using only a single final and the one driver is being modulated, there's one less transistor, so a third of the load is gone basically. So yeah, I had this thing and I'm running a sweep, and I want to show that because I forgot there was something else the customer had asked me to check on this. But I've been sweeping an audio signal through this thing for a considerable amount of time, and yeah, it got warm. I mean, honestly, it got about as warm as most radios get with just normal talking. And I was hammering this thing, and yeah, it just, warm. That's about all. So yeah, like I say, waste of time. And actually, let's grab the schematic, which is somewhere around here. I know I got it out because I was just using it. And let's see, do I have it? Yes, it is upside down. So it's real easy to see that they don't do anything. So let's see, where is my pointy stick again? Okay, and we see the tip 36 right there. Okay, that's the regulator transistor right. The camera swung back. It's this big guy right here that people replace with the Max Mod. Waste of money. Smoke and mirrors. So anyhow, tip 36. Your output, follow it over, comes down. I'm trying to stay in a camera view here. Comes across. Okay, that's the bottom line. Okay, and comes to, here's the two little jumpers back here that, where are we at? That's right there, those two little guys you take out when you're doing your bias adjustment. Okay, so your audio comes in, goes to the pre-driver, or the driver, and then also to the final. Notice these are the RF, yeah, here and here. Here's your RF amplifiers. They are not connected to this, okay? They don't get any audio. The only thing that's being fed audio is the final and this driver here. These two amplifiers are volted, okay? Those are connected directly to the power jack, basically on the back of your radio. If you follow their voltage source across, you'll see they come through the coil. Trying to find in the picture here, where in the heck does it go? I can't see over time. Look here, okay. Right there, up, yeah, okay, so you come through here, through this coil, come down, come across right there to SB. SB is the power jack on the back of the radio. Flip the schematic over and around here, and I can show that. Right there is the power jack on the back of the radio. That's the big ferrite core right there that they glue in. Okay, so that's our positive line, and right there is the SB. That is a direct feed off of the power jack. So those two, what most people would consider finals, are basically just an amplifier. It's basically a two transistor amplifier in the radio, but it's just inside the radio. So like I say, it really doesn't do a lot. Now, the customer had asked me, I've done Lincolns for him, and I have done the, I slightly increase. Keyword there, slightly, not a hi-fi mod. Bunch of hocus pocus if you try and doing that shit to an AM radio. you can only get so much fidelity out of a CB. But the Lincolns have a fairly, and that varies from person to person, because everybody has different, how should I put this? I don't want to say audio characteristics, but their opinions on what good audio sounds like. Some people note that the audio on a lot of these radios, President Lincoln too, they sound a little bit pinched. They have a fairly narrow audio pass band for your audio from your microphone. So when you're talking, it attenuates rather fast, and it just sounds a little bit pinched. He wanted to know if I should do that modification to this radio. I told him I don't know. I was like, because I really, like I say, haven't played with a lot of these. So I told him, I said, once I got this one back in factory condition, I would hook the signal generator up to it and sweep an audio signal through it just to see, and we'll see what the audio characteristics are of this radio. I'm going to say it's better than a Lincoln. It's a little bit wider audio band pass, but could it use some help? Yeah, probably. So let's just show it. So test conditions here, we have microphone cable. We're hooked up to the mic jack here with the cable. Comes into the isolation transformer. That cable goes up to the signal generator up here, which we are sweeping a signal from 100 Hertz to 5,000 Hertz in a time of 5 seconds. Okay. Everything else down here is basically set up like it was before, so the watt meter, spectrum analyzer, and the oscilloscope. The bandwidth on this is set to 10 kilohertz, so 1 channel spacing, and I'll just flip the radio into transmit, and I also have, so you can actually hear the transmitted audio, I have the Yaesu FTDX3000 over there set to the same channel, and I already have the volume turned up and the squelch turned up. That's why you don't hear a bunch of static. So we'll put the radio in transmit and see what it looks like, and I'll show you what I mean by it is a little bit pinched. So you can see how we've got good modulation, and then it starts to drop off. And the same thing if you look down on the spectrum analyzer, you can see the peak starts to drop off. And actually what we can do, we don't need to listen to that all day. Let me just turn the Yaesu off. Let's put on a trace, and we'll pick max hold, and we'll let that sweep through a couple times. Now what that's doing is I have set it so that the trace is just what it says, max hold. So it's going to record those peaks, and it's just going to build up until it fills in here. So that is our frequency response there. There's our, of course this coax cable is just slightly in the way, isn't it? That little peak right there, that's our carrier. So let me zoom in a little bit. Okay. So that is our carrier, and then we have the lower and upper side bands. And you can see it's fairly flat. That's actually a little bit wider than the President Lincolns. They're a little bit narrower than this, but you can see it drops off, and I actually have a marker right there, because that's approximately our 3 dB point. So if we come up to where it's flat, we can see we've got minus 17.44 dBm there. So we want to go 3 dB down from that and find our 3 dB point. So that would be 20.44 approximately. So, and 20.26, oh, look at that, 20.44. So that is our 3 dB point, and that's at 27.207683. Our center frequency is 27.205, so that would be approximately 2,683 Hertz is our 3 dB point, where it starts to attenuate and really drop off. Now, you can see where it flattens out here. That's basically out at the audio, that bandpass filter's filter edge. That's its maximum attenuation there. But you can see we still have a little bit over 1,000 Hertz before we reach the edge of the actual channel. So if I can bring this point over maybe about another 1,000 Hertz, that should push this over to where it'd just be almost, we'll still be down fully attenuated, So, you know, we're not going to be bleeding into the next channel, because that's what we want to do. We want to keep this sloping part out of the next channel. So as long as we can get that pushed over as close as we can get it, but not get any of this, basically this angle here falling off the screen, you know, move this point so it's fairly flat over to about another 1000 hertz. That would push this edge over about another 1000 hertz. So we'll gain about another 1000 hertz of audio bandwidth. We'll gain about another 1000 hertz of audio bandwidth and audio fidelity. So zoom out here. So I need to take a gander at the schematic. The circuits are similar. I've looked at the Lincoln, looked at the schematic for this one. They're similar, but they are different. They use basically still the same circuitry, but it is pretty much all of the values are completely different in this radio. So yeah, I need to play around with that, and I think I can probably basically just do the same values that I used in the Lincoln. I may have to tweak that a little bit, because some of the rest of the, you know, the circuitry in this radio is going to have a little bit different characteristics too. But yeah, I'm going to play with the bandpass, the microphone bandpass filter, see if I can get that widened up about another 1000 hertz, and I'll come back and we'll run that on, so, you know, keep a picture of that in your mind. Or you can just, you know, once the video gets uploaded, you can just scroll back to this point. But keep an eye on, actually what I should do is save that. That's what I'll do, because actually that's already, it's held on the screen right there. What I'll do is I'll save that, something I don't really do, so I need to play around with that in the storage menu. I'll save that trace, and then we'll run this again, and I should be able to call up that trace originally and overlay that on our new spectrum sweep to see the difference. So let me get to it here, and let's see if we can get this improved a little bit. Okay, so it worked out as planned. We've now bumped out the audio bandwidth so it's flat for about another 1000 hertz, but still keeping within the 10 kilohertz channel spacing, so it drops down at the bottom of the knee is still within our channel spacing, so we will not be bleeding anything into the adjacent channels. So same test setup as before, little adapter board with PTT switch, and to feed our audio in goes to the isolation transformer, which as before goes up to the signal generator. It's still sweeping from 100 hertz to 5000 hertz in a 5-second time frame, and then we'll be monitoring the output on the oscilloscope and the spectrum analyzer here. As before, we have center frequency set to 27205, and our bandwidth is set to 10 kilohertz, so we're looking at 1 channel's worth of spacing. And I'll flip into transmit. And you can see it stays level out, because it was originally to about right, I think, here, and now you'll see it's flat to about right here, and then it starts to drop off. And actually, if we do our trace again, and I'll actually have to show this on the computer, because I did save the original trace to the thumb drive there, so I'll have to let this build up, and then I'll have to save this trace, and then I guess I can see if I can overlay them on a computer, or at least do them side by side. I've never had to do this before, saving the waveform to a thumb drive to view later. So, but as you can see, we're originally, our knee began right about here, okay, and then started to drop off. You can see our knee has moved out about 1000 hertz, and I've got our marker again set. So you can see if we go up here, you can see we're at about 17.47, so we're going to be looking for that 3 dB down point, which would be 20.47. And I'd say right about there, minus 20.36, and we're at 27.208.583, so that would be 3,583 hertz audio. So it's flat for about another 1000 hertz. And you can see at the bottom of this bend here, we can see it just flattens out. So like I said, wanted to keep this so it was just, we could bump that out to where it just reached our channel edges, but without it, you know, bleeding into the adjacent channels. So we have absolutely no additional energy going off into the adjacent channels now. So it worked out as planned. So let me take this out of transmit, and I'll save that. Let's see, print. I'm not going to sit here. I actually typed it out on the first one. I'll just put in, let's see, go to numbers, 955. Okay, and it's going to save it. And I'll see if I can get those transferred over to the computer, and then I'll meet you back over at the computer screen if I get this to transfer over. Like I say, first time. I usually don't have to save waveforms to a thumb drive to view later, but why not? If we can do it, we can do it, and what the heck. Okay, so we're over here on the computer screen, and I can't overlay them, but I did bring both of the pictures up. So you can see, here's our original one over here, and you can see this was the original bandwidth, approximately how wide it was right here. And then it would drop off, and we had our, at the bottom of attenuation here, and then you can see how much wider it is here, how it stays nice and flat for a considerable amount more, drops off, and then just knocks off right before we get to the channel edge. So, you know, perfect. We've attained more audio frequency spectrum with a flat response, but we have still stayed within our 10 kilohertz channel spacing. So project successful. So yeah, basically these are basically the same as modifying the President Lincolns. Basically any of those radios that use an active low pass filter, modifying them is going to be pretty much the same. Values may vary a little bit, and if you're wondering about the drop rate here in the low frequency, this has absolutely nothing. This drop, or where it starts to pick up, that has absolutely nothing to do with that filter network, with the active low pass filter, because it's a low pass. It's passing this and blocking the higher frequency content, because that's what that filter is used to do. It's used to narrow the transmit bandwidth so it does not exceed the channel spacing. So it limits the high frequency cutoff. That's what it's doing. It's filtering off the high frequency content. We've expanded the high frequency content from about here to here being flat, or our 3 dB point, but it did not change at all the low frequency. There is a little bit of drop here on the low frequency. That's not really noticeable, quite honestly, at that low of a frequency. So you could probably play around with the rest of the audio circuit, but like I say, that has absolutely nothing to do with the active filter circuit. But yep, that looks good and sounds good. So now I can get this one boxed up, and I can send at least 3 radios back now, and then I'll get started on that pace. I'll do, like I say, that'll be a completely separate video, because that's going to be an entire restoration. So we now have 3 radios that have been dedusted and did a little bit of modification work to the Stryker, and I think he'll be happy with that audio frequency response now on that. Like I say, it's a little bit better, and he's using good microphone. I'm not sure which one, but he's using either his Turner's or like his A-Static 575, so they have a very good frequency response to start with, so they'll be the perfect match for a radio like this. So I hope you enjoyed.